Alright, so I asked you as a warm-up problem to factor 3x squared minus x minus 2 and also to solve it, and you get this as your answer, right? Okay, how would you write this a little bit more friendly? 3 times what? Sine of x squared minus sine x minus 2 equals 0, right? Okay, well, we already did all the math, right? If you factor this, that's one way of solving quadratics, right? To the power of 2, you set it equal to 0, and factoring is the easiest and fastest, but doesn't always work. So if I factor this, I'll have 3 what? Tell me. 3 sine x plus 2, and what? Sine x minus 1. Okay, then we already did the work, so when we solve it, sine of x is equal to negative 2/3, and sine of x is equal to 1. Okay, question? To solve for x, are we going to divide by sine on both sides? No, we take the inverse. So the inverse, let me zoom in now. You have the inverse of sine of 1 equals x. That should be an inverse sign. That basically says, where is sine of an angle 1? Yeah, I noticed that this is not a fraction. If it's not a fraction, it's not a special right triangle. If it's 0 or 1 or a negative 1, it's going to be a quadrantal, which someone said at pi over 2. You look at your unit circle. Cosine sine. Sine is 1 at pi over 2. Okay? Class, how would we solve this one? Inverse. So I have the inverse of sine of negative 2/3 equals x. Question. Is negative 2/3 on your unit circle?
No.
What does this imply? It implies that we're finding an angle that's not a 30, 45, or 60. It's an in-between. Does that make sense? So, I can actually put this into my calculator. This is a calculator-ready equation, and we're using radians. So go ahead and take out your calculator. Make sure it's on radian mode. How do you get to radian mode? You press mode. And then you just highlight degree. If it's on degree, radians, press enter. And then second, quit. So I know that I'm on radian mode. I just put this calculator command in. Second sine negative 2 divided by 3. Remember the negative buttons there. Press enter. I get this. X is equal to negative 0.7297. Okay, what does this mean? You are correct. This is radians. This is essentially a reference angle. Okay, so let's think about this. Let's draw a unit circle. If you don't know how to draw a circle, just draw a coordinate plane. And then the radius is the same, so if I choose 4, so 4, 4, 4, 4, and then you make your wonderful sketch. Like my circle? me to show yours? Okay. Where is sign negative? Put your fingers on there. What quadrants?
3 or 4.
Acronym? This is where they're what? Positive, okay? So we don't need these two. Now, keep quadrant 1 open. Alright, this is what I want you to do. Class, X here represents an angle, right? Is the angle in degrees or radians? Radians, okay? And it's radians in decimals. You're used to radians in what? Fractions. For example, what's a radian you know? A quadrantal. Someone said pi. Pi is equivalent to what? 3.14 radians. Are we okay? Alright, take 20 seconds with your partner. Go ahead and fill out the rest of the unit circle in radians in decimals. So decimal radians. Ready, set, go. Andrea. Here. Pi over 2 is 3.14 divided by 2, so approximately 1.57 radians. Raise your hand if you got that. Good. Look, 1 pi over 2 plus 2 pi over 2 gives you what? 3 pi over 2. So if you just add these two, you'll get this one. Omar, what'd you get? 4.71 radians. Raise your hand if you got that. You could have just put in 3 times 3.14 and then divided by 2 in your calculator and you'll get 4.7. Okay? In class, this one is what? 0 and which is 6.28 radians. Okay? Okay. Put your pencils down. You can copy later. You just need concentrating power now. I'm going to use the absolute value of this. What does this mean? It's a negative angle, but I just want to talk about a positive angle. And this is your reference angle. Everyone say reference angle. So if I draw a triangle in quadrant 1, we just found this reference angle to be about 0.7297. 0.7297. You're just watching. And then if I put another color, your favorite color, pink, talk to your partner. What do you know about orange plus pink? Ready, set, go. Jade, orange plus pink equals? Pi over 2 is correct. Class, if I cover up the triangle, you have what type of angle here? A right angle. Two angles added together, those are called complementary angles. Now, the old formula was blank plus blank equals 90 degrees. We have radians here. Blank plus blank equals pi over 2. We're using decimal radians, so we're not even using pi over 2. We're using blank plus blank equals 1.57. So if I put in 0.72, that's a 2, 97. And I basically need to solve for the pink. So you can call it, I don't know, x, and just subtract. So I just type in my calculator. 1.57 divided by, subtracted by 0.7297. Why did I do divided by? Subtract 0.7297. And that gives me 0.8403. The pink area represents 0.8403 radians. Okay. Here's what you really need to do. I just helped you understand the reference angle, which is what color? Orange. Remember the bow tie? You guys remember the bow tie?
Yeah.
And then the complement, which is pink of that angle. But remember, sine is what? Negative in which two quadrants? 3 and 4. So this is what I really want. I want you to do your homework. And I want you to find the angle starting from standard position. So where my pen is, rotate it all the way around for the blue triangle and the green triangle. Okay? I don't know if that makes sense, but help each other understand what we've done so far, and then I want the angles measured in radians for the blue and the green. Ready, set, go. Alright, someone pick a color, green or blue?
Green.
Alright, let's do the green triangle, okay? Now this might help you. Where would you put the orange, inside or outside?
Inside.
It's the reference angle, right? And the pink is where? Inside or outside?
Outside.
And you really don't need it for this problem, the pink for our green triangle, right? Alright, here we go. I'm trying to make a angle starting in standard position, like my pen, and we just keep rotating it, right? So if it starts here, it's purple. I'm going pi over 2, or 1.57. 3.14 plus the orange. Do you see that?
Yeah.
So really it's 3.14 plus what? Plus 7297. And that gives us 3.8697 radians. So the angle that I really wanted to find, x here is our answer is put over here. 3.8697 radians. That's for the green triangle. Okay? Explain to your partner how we did the green triangle, and then I'll give you guys some time, and then you'll get the blue triangle. Yes, Jocelyn, tell us how to find the blue triangle's angle. Tell us how to find the blue triangle and its angle.
What I did was, instead of adding the pink, adding the orange, we added the pink.
Correct. So you use the pink, and what did you add that to? Correct. So we're starting here. 1.57. 3.14. Then you're going all the way over here to 4.71. And then she's not adding the orange, but the pink. So that would be plus 0.8403. And if I use my calculator, good thing I'm not doing a calculator check right now. Let me mess up. 55503. What does that mean? That means if you picked any of these three x values and you put it back into this equation, it'll equal 0. What would have made our lives a lot easier is if they changed the interval to be degrees. And they just gave us radians. So that's what was new about all the decimals there.
I love math. You don't love math? What's wrong with you?